Our next projectile example is a ball is thrown to the top of a building that is 5 meters above where it was thrown. The initial velocity was 16 meters per second at 50 degrees above the horizontal. What is the ball's hang time, max height, and the range? Alright, so we have this ball, we got a building that's 5 meters tall. Thrown upward or kicked or however it's projected forward, it's going to be 16 meters per second at 50 degrees above the horizontal. We're going to have a horizontal and vertical component to our vector, to our velocity. The information we know the y direction is going to be negative 9.8 meters per second squared for the acceleration. The x direction, acceleration is 0 meters per second squared. The initial velocity, if you take the y component is the upward, it's going to be opposite, so it's going to be 16 sine of 50 degrees, which is 12.3 meters per second. The x component is going to be 16 cosine of 50 degrees, which is 10.3 meters per second. We also know that from the beginning all the way to the end, the total displacement is going to be 5 meters in the vertical direction. Alright, so given that we have the acceleration, the initial velocity, and the displacement, in order to find the hang time, we're going to use displacement in the y direction equals 1/2 times acceleration in the y direction times time squared plus the initial velocity in the y direction times time. Plug in the information we know, we got 5 equals 1/2 times negative 9.8 times time squared plus 12.3 times time. Subtract 5 from both sides, and that gives us basically a quadratic equation where we have some value here, a times a variable squared plus b times a variable plus c. Alright, so using the quadratic formula, we're going to plug in b is negative b, so that's 12.3 goes there, plus or minus the square root of b squared, so 12.3 goes in there, minus 4 times a, negative 4.9, times c, which is negative 5, all over 2a, so 2 times negative 4.9. We get two answers from this. We get 0.5 seconds, or 0.51 seconds, and we also get 2.00 seconds. Now, the question here is, which time are we interested in? Which one is the correct one? Because both of them are positive, so it's not really that easy to determine which one is correct. Now, if you look at the diagram, remember, these two times are basically the 2 times of two sides of a parabola. If you look at the parabola, it goes up here and then back down over here. So at the same time, or I'm sorry, the same elevation, we have two different times. 5 meters above the ground, this is going to be at 0.51 seconds. This one over here is going to be at 2 seconds. So 2 seconds is actually the one that we're wanting based on our diagram. There's nothing in the problem that says we're talking about the velocity as it's coming down or the time when it's coming back down as opposed to the one going up, but the diagram is what indicates that. Alright, so our time being 2 seconds. In order to find our max height, we know that the displacement in the y direction is going to be, the velocity in the y direction is 12.3 meters per second. The acceleration is negative 9.8 meters per second squared. We're not going to use this displacement because we're trying to figure out where it is the highest at, so we don't have a displacement of 5. It's actually going to be above that. But we also know that the final velocity in the y direction when it gets to the top is going to be 0 because all of this velocity is going to decrease by 9.8 meters per second every second. Alright, so final velocity in the y direction squared is going to be equal to initial velocity in the y direction squared plus 2 times acceleration in the y direction times displacement in the y direction maximum. Plug in the numbers that we know. Go ahead and square 0, you get 0. Square 12.3, you get 151.29. And then 2 times negative 9.8 gives us negative 19.6. Subtract 151.29 from both sides. Divide by negative 19.6. And we get that our displacement in the y direction maximum is going to be 7.72 meters. Alright, in order to find the range, we need to look in the x direction. Well, in the x direction, we have acceleration. We have acceleration in the x direction of 0 meters per second squared, and the initial velocity is 10.3 meters per second. That's not enough information. We actually are going to need to use this time in order to determine what the range is going to be. So displacement in the x direction equals 1/2 times acceleration in the x direction times time squared plus initial velocity in the x direction times time. 0 times 2 squared times 1/2, that part goes away because it's all being multiplied by 0 acceleration, as you can see right here. So that leaves us with 10.3 times 2, and that leaves us with 20.6 meters as our range. The next example problem, let's say we accidentally throw our keys at 8 meters per second at 30 degrees down from the horizontal from a cliff that's 64 meters high. How far from the base of the cliff do you need to look for your keys? Now, if we're talking about how far from the base, then what we're talking about the displacement in the horizontal direction, which is range. Alright, so we have our object that's 64 meters above the ground. We throw downward, so a negative y component is going to be from the 8 meters per second because it's downward. It's to the right, so we have a positive x component but a negative y component, 30 degrees down from the horizontal. Alright, so the range is what we're going to be looking for. In order to find range, if you remember from previous problems, in order to find the range, we usually need to find the hang time first. So let's figure out the information we know. We got this, acceleration in the y direction is negative 9.8 meters per second squared. Acceleration in the x direction is 0 meters per second squared. Velocity initial in the y direction is going to be the downward component, and that's going to be opposite, so it's negative 8 sine of 30 degrees, which is negative 4. That negative is very important to make sure that we're throwing it downward as opposed to upward. And then the y component is going to be 8 cosine of 30 degrees, which is 6.93 meters per second. Alright, so first we need to find the hang time using the displacement in the y direction. So displacement in the y direction is going to be equal to 1/2 times acceleration in the y direction times time squared plus initial velocity in the y direction times time. Plug in the information we know. Displacement in the y direction is going to be negative because we're talking about downward. It's going to end lower than where it started, so we got negative 64 equals 1/2 times negative 9.8 times time squared plus negative 4 times time. We're going to add 64 to both sides. Take half of the acceleration, you get 0 because negative 4.9 times time squared minus 4 times time plus 64. This is a quadratic equation, so let's go ahead and use our quadratic formula. Plug all of our numbers in. We got b is in for negative 4, and then we got a is in for negative 4.9, and then c is 64. And we get 2 times. We get negative 4.05 seconds, or we get time equal to 3.23 seconds. Alright, so with these 2 times you can see that it makes sense that the positive time is going to be the one that we're going to use. So we use 3.23 seconds as our hang time. The other time is the other side of the parabola. If we went backwards in time by negative 4.05 seconds, we would get the other half of the parabola. So using this as our hang time, we're going to find the range. In order to find the range, we've got to use displacement in the x direction equals 1/2 times acceleration in the x direction times time squared plus initial velocity in the x direction times time. Plug in the information we know. We have an acceleration of 0, so this first part here cancels out, and we're left with our constant motion equation where displacement equals velocity times time. We plug that in, we get 22.4 meters as our range.